Okay, here we go. This is video 2, Roman numeral 3, reduction formula, and the goal here is to, more than using the reduction formula, it's going to be more about developing the reduction formula. So this is sine to the power of n x dx, and we're going to use integration by parts to develop a formula. So in integration by parts, I need a u and a dv, and see if you can think about what this would be. Let's pick a dv that we can easily integrate. Sine x dx is a good dv. And then that would make a u sine to the power of n minus 1 of x. Okay, so let's go through our integration by parts. Du is going to be n minus 1 sine to the n minus 2 power of x times the cosine with the chain rule, cosine of x. Now your v is simply going to be negative cosine of x. Of course, over here it would be helpful to have a dx. So there it goes. So now using our integration by parts, this is going to be negative cosine of x times the sine to the n minus 1 power of x, that's u times v. Then I need a minus v du, but I have a negative, so it's going to be plus the integral of, let's do that product. So I have an n minus 1 sine to the n minus 2 power x, and then I have a cosine squared of x, and then of course the dx. Okay, so I'm going to do a little bit of manipulation. So negative cosine x sine to the n minus 1 power of x plus, now watch what I do here. First I'm going to pull out an n minus 1, and then I have the integral of sine n minus 2 power of x, but the cosine now I'm going to use an identity and call that 1 minus sine squared x dx. Okay, moving along. So this is going to be negative cosine x sine n minus 1 power of x plus n minus 1. Now I'm going to multiply that over a distributed property, so this is going to be sine n minus 2 power of x, so that distributes here. Then I'm going to say minus, of course I need an integral here, minus the integral of sine to what power? Well, n minus 2 times squared, so that's going to be to the power of n x dx. Pretty cool. Okay, moving on from there, we have negative cosine x sine n minus 1 power of x plus, let's break this into two different sections, the n minus 1 times the sine squared n minus 2x dx, forgot that guy there, oops, and then we have minus n minus 1 integral sine n x dx. So that looks good. Where do I go from here? Well, I'm happy to have this sort of repeat itself. Feels like I'm in an infinite loop, but if you remember, if I add this to both sides, so I'm going to add this quantity here, and by both sides, this is the other side. So when I add that to the other side, I get, so I'll say therefore, n sine n of x dx integral equals negative cosine of x times the sine n minus 1 power of x plus n minus 1 quantity times the integral of sine n minus 2 of x dx. Lastly, I'm going to divide out the n, so I have the sine n of x dx equal to negative 1 over n cosine x sine n minus 1 power of x plus n minus 1 over n integral sine n minus 2x dx. Wow, that's the whole goal of example 1, is to develop this formula. It is a reduction formula because I started out with the power of n. Let's say that was to the power of 5. If I did this process, I then would have to the power of 3 integral. I could repeat that process, bring it down to the sine to the power of 1, and then at that point I actually know what that integral is. Example 2 will show you more what I'm going with, or where I'm going to. So here is example 2, the one I was talking about, the sine to the power of 5. We're going to utilize the reduction formula. Perhaps you want to try this on your own first. So by reduction formula, this is going to be negative 1 over 5, like negative 1 over n, cosine of x, sine to the power of 4, reduced by 1, plus 4 over 5, n over n minus 1, or n minus 1 over n, times the integral of the sine, and this got reduced to the power of 3 dx. Okay, so I'm going to re-employ the reduction formula on that portion. So let's first repeat this. Cosine x, sine to the power of 4x, plus 4/5. Now that 4/5 is going to be distributed, and I have a negative 1/3 cosine of x sine squared x plus 2/3 the integral of sine of x dx. Alright, so here we go. We have negative 1/5 cosine x sine to the power of 4x. Let's distribute, so this is going to be not a plus but a minus. 4 over 15 cosine x sine squared x. This coefficient here is going to be plus 8 over 15, like that, and then the integral here of sine of x we know to be negative cosine x. So look at that, that's going to be a minus 2. So minus 8/15 cosine of x plus c. Yay, there it is. We've used a reduction formula to find the integral. The problem with that is it requires memorization. Not a huge fan of the memorization, but they do exist. There are also a whole host of other reduction formulas, and I'm going to present them on the screen here. Here's the list. You might want to press pause and write these down. You can see some similarities in the ones we discovered. So what would I be looking for in a testing situation? Not that you would commit these to memory, but that you might prove these using integration by parts. Question may say, prove this is true using integration by parts. And the next part, Roman numeral 4, talks about trigonometric integrals. This is more about using a guideline in order to integrate. So once you do these a couple times, it's not memorization, it's more of a procedure. And what we're going to do is we're going to look at the same integral that we found before. It's going to look different, the answer, but we're using a different strategy. This is one that you will use quite a bit, so it's worth watching here. I would press pause, look at the guidelines, become familiar with that gray box, see if you could figure it out. But then just listen to how I do it, and I think you would find that this is a pretty easy procedure. So the idea here is to get the sine of x to some power squared, then to have a trailing sine x by itself. So I would need a sine squared x squared. What this does for you is allows you to use the identity for sine squared, so 1 minus cosine squared of x to the power of 2 times sine x dx. Then what happens is you simply do a u substitution. So let's let u equal the cosine of x. Du then would be negative sine x dx, and dx of course would be negative du over sine x, which would cancel out this and bring a negative in front. So what that does for us is it gives us negative, there's the negative from here, brings us a negative, then we have 1 minus u squared du. Then it becomes a very manageable when in a jam expand type of situation. We could easily integrate this. I'm going to expand it, FOIL it. So 1 minus 2u squared plus u to the fourth du. And we keep going from there, and that final answer is going to be negative u plus 2u cubed over 3 plus u to the fifth over 5, that's a minus, and plus c. Then we have to convert back to x, so negative cosine x plus 2/3 cosine cubed of x minus cosine to the power 5 of x over 5 plus c. This is a much more desired method. If this was to the power of 7, you can still do the same process here. This would sine cubed squared, and then it would just simply be 1 minus u cubed squared, and you go from there. So fairly easy process. You will see examples 2 and 3 in the homework assignment. In part 5, similar situation. You have a gray dialog box. I'm going to ask that you read it, try the problem, fairly easy, but as you follow along after trying it yourself, I think you will see some similarities to the last one. So I'm going to write this as the integral of tangent squared x, tangent x, and then I'm going to write this as secant to the power 4x times secant x dx. Now, why is that helpful? Well, here we have secant squared x minus 1 using an identity times secant to the power 4x, that's this term here. Then I still have tan x secant x dx. And we will say here, let u equal the secant of x. Du is going to be secant of x tangent of x dx. And you see that this quantity here cancels out, and we're all in terms of secant. So then I have the quantity u squared minus 1, u to the fourth du, distribute and integrate. So the integral of u to the sixth minus u to the fourth du, we have u to the seventh over 7 minus u to the fifth over 5 plus c equals our final answer. Converting back to x, we have the secant to the power of 7x over 7 minus secant to the power of 5 over 5 plus c. That is the end of lesson 2. Please do the homework in class carefully so that you cement all these concepts.